Good morning. So I'm Bill Wagner. We're going to be looking at pattern matching in C#7 this morning. So most important things in this slide is how to reach me via email or Twitter. If you have any questions after this talk, go ahead and reach out there. We'll post both the slides and the demos on my GitHub repository later. I will announce it on the Twitter handle. Okay, so we're going to talk a little bit about the languages and where C# is going. And C#7, primarily the investments are evolving for modern patterns. Distributed applications. So if you think of when C# first came out as a language, roughly 2000, we wrote desktop applications, maybe client server, maybe websites, mostly static pages going down in forms. That's very different than the programs we're writing today. We're writing small services that run on distributed machines. That leads to a different decomposition of problems. Objects aren't necessarily the right way to solve every problem. We're more often separating data for transit from the algorithms that operate on that data. That's probably the big theme of C#7, is things like tuples, pattern matching, and others. For anyone who was in Kathleen's talk, she gave a good overview of all of those. Now, one of the things that we really like as working with the C# team is C# is one of the most popular technologies out there, according to the Stack Overflow survey toward the end of 2016. And the set gets a little smaller. If we look at the most loved technologies, C# is one of a very small set of languages on both of those lists. So it's used by a really, really large number of developers. And by and large, the developers that use C# like it. So it's an important goal for us, is to keep that and hopefully move up on both of those. F#, of course, has a little more love, which is nice. They're good people. Okay, so let's look at some of the big things that have been going on in C#. Instead of running on Windows, we now run everywhere. Just to show that we do still have support for Windows. Today's demos are on Windows. My talk Wednesday was all on a Mac. So we do still support Windows, just, .NET is a system component. More and more with .NET Core, you can deploy .NET with your application. That's going to make side-by-side a little bit easier as we get a little bit more investments there. It's going to make it easier for things like running in Docker containers and so on. You can deploy something that's totally self-contained. Running on a VM and a CLR, we're now also making investments into compiling C# through .NET Native into native code on various platforms. So you'll be actually running native code that started as C#. Compilers have open APIs, the Roslyn APIs. If you were here last year, I gave a talk on building Roslyn analyzers. There's been further investments in that, so you can continue to do open compiler APIs and add your own hooks. Edit in your favorite editor or Visual Studio. Once again, some of the demos I did Wednesday were in VS Code. Today I'm going to use Visual Studio. Proprietary, everything is open source. So as I discuss pattern matching, toward the end of the talk, I'll show you how to find this spec for patterns and investments that will go on beyond C#7 as we do more things with patterns. And you can engage in the discussion there directly on GitHub on the Roslyn repo. Okay, so let's look at pattern matching as a definition and what it means for C# developers in terms of what you've already done with code and the kinds of things that we're going to do. The definition I want to use for pattern matching is that we are going to test that a value or variable has a certain shape and extract information when it does. So there's three keys to that definition in terms of what we're going to learn about pattern matching. First, we test something about a variable. Not necessarily its type, not necessarily its structure, in terms of a normative way. C# types, classes have names, and so on. But we're going to test something about a variable. Has a certain shape, certain properties, certain values in those properties. And then we are going to extract information when it does. So once we've found what we're looking for, we're going to do something with that variable. Now, we already do that, but the syntax is a little bit clumsy. For instance, this is some of the code that we're going to start with. if you look, this is the kind of code that we would have to write today to test what type of an object comes in. There's a lot of if this is some type and so on. And then we move down and then we'll do a cast because we figured out what type it is. So those are separate operations. We're going to perform some tests, and then we're going to, if that test succeeds, then we've got a block of code that does some work on that variable. That's a little clumsy. This is structured to be somewhat clean. My last two demos, I'm going to try to do pull requests for a couple live projects to change from code that's noticeably uglier than this into using C#7 pattern matching. So that's going to be our key here. So what we're going to do is we're going to take this test. Wow, that really is in the wrong spot there. Wow. And test a value and then bring it back and extract at the same time. In C#7, we're taking some small steps toward pattern matching. There is a rich vocabulary for patterns. If we look at the spec, you'll see a lot of them laid out. C# has three particular ones that are supported that are new. First of all, there's the constant pattern, which to some degree is already supported. You can test if a variable has a certain value. We're comparing against a constant. Well, now we can compare and extract at the same time. We have a type pattern. We are going to test that a variable is a certain type, and we'll extract into a new variable that type immediately in one expression. And then there is the null pattern, which is kind of a special case of the constant pattern, but is interesting because null doesn't necessarily have a type. So we're going to look at those three supported patterns, and there are two statements that work with that. There's been enhancements to the is statement, and there have been enhancements to the switch statement that support these patterns. Okay, so what we're going to get is is expressions to test if a variable is a certain type, and if so, we'll extract information from it. Switch and case expressions that can test a type and extract information from it. And the switch is further enhanced with a when conditional, so we can test the type, and if the type matches, we can apply further tests that look at information and properties on that particular type. So let's start exploring a little bit. So here's our main demo. I've built a console application that declares several different variables with some interesting or non-interesting values. So I've got a couple integers, so we know that's a struct, actually has values, has numbers. I've got a nullable int. First one is the null value, or the default value for a nullable int. I have a couple different numbers there. And then we have strings, and I put a few interesting cases there. I've got null as a string. I have the empty string. I have just a white space string, and then just a phrase. And then I've built a structure that's a point structure up here. Simple Cartesian points, x and y, override a toString so we can print some things out. And then I've built a few interesting points. One that has, at the origin, 0, 0. 3, 4, nice little Pythagorean triangle, and 23 and 19, which are two prime numbers that add up to 42, because that's how we roll. Okay, and then I've just built an array of objects that has each one of those in, and we're going to walk through and convert both this ugly code for is patterns into using pattern matching, and then we'll do the same thing with the switch expressions. And if I run it right now, I'm going to pass in turn each one of these different variables into these tests below that say, all right, is this an integer? Is this a nullable int? Is it a string? And is it a point? And if so, then I'm going to cast it and then print out a little information about it. So if we run it, we'll find, okay, so we've started our is expressions. I found two integers, 0 and 42. Interestingly, I found two more integers, 0 and 42. Found strings. Notice that there are 3. And I found 3 points. Okay, that's all good. So a few interesting things we learned right away from this code is that it never finds the null values. Okay? If we look through this, it never finds the null string or the nullable null int, because null will fall through both of those is tests. Notice it doesn't find the null string either, because an is on a null string, well, it's null. It's not really a string, is it? So those tests are already failing. And the final interesting one is notice that even though I'm testing for a nullable int, I never wrote out that we found a nullable int. Everything we found actually already did the cast and cast it to an integer. So we never actually found that type. So because of the rules of how conversions happen, this code is a little bit interesting and already has some subtle issues with it, depending on what we were trying to do. And finally, if we look at the code itself, we can see a couple interesting little bits of ugliness here. If you look at where I'm testing for an integer, or a nullable int, where I'm converting it to an int, and where I'm testing for that point, which is a structure, I have to use a cast rather than the as operator, right? Because we can't do is with value types until now. Okay, so let's start to rewrite some of this and use pattern expressions. And what we're going to find is the code's going to get a little shorter, it's going to get a little cleaner, and it's not going to make as many mistakes. So first we want to test and see if it's an int. So what I'm going to do is I'm just going to say if my object to test is an int I. So I'll do the assignment right there on the is statement. And notice that now with the is, okay, I can check to see if it's an int. I'm going to do a assignment, life is good. And I'm going to just copy that right line right up here. All good. So that one so far is pretty good. Great. Okay, so we've gotten rid of about 2 or 3 lines there. We're going to do the same thing here for my nullable int. That should work. We'll leave this. Let's not make that one. So now what's interesting with nullable ints is that first one, that object to test, if I check to see if it is an integer and assign it, that will work with a nullable int that has a value, because I can convert that integer can convert the nullable int to an int directly. So let's just go ahead and run right now. And now what we'll see is we get pretty much the same result as we had before, except that I'm getting build errors. I missed my skeet. Oh, yes. Right. So let's change that one to J down there. There we go. Okay. Cool. All right. So we still convert our nullable ints to ints. Cool. Now what was interesting is that the only thing that's really getting checked here that we find is if that nullable int actually is null. Okay, so let's check that null pattern. So if object to test is null, and then of course we're not going to try to do this cast because that would clearly fail. Okay. And now you see that we find the nulls both for the nullable int when it has its default value, and we find the nulls for the string. Is the first one of the strings now points out that we found a null. All right. So far, so good. Now let's start to expand and really look at the string and say that, there's a few different things that we can do here that's really fun. So we found a string, we found a point. Well, now let's really start to play and add new other interesting things that we want to test for. Let's say I want to test for an actual value. So up here I'm going to say if object to test is int, we had a 5 up there if I remember right. Oh no, we had a 42. Which we can't do with those. We're going to start adding those in the switch. So now to expand this, let's look at our switch pattern, which gives us quite a bit more interesting things that we can do. So we're used to a switch in general, and that we can put a few things under the constant pattern. Well, now what we can do is we're going to be able to switch on any type. So I'm switching on object. So I'm going to build case labels based on what we find in that object. And here, similar to the is statement that we had up above, I'm going to say if, or case, int I, and we'll just do the right line. There. Okay, so far we've just added that one particular case. I can run through, and now you can see as we start on the switch expressions, we're starting to find some things with different integers. Okay. Well, values are still important. So let's now say I have case int I when I is 42. And I deleted my opening brace there accidentally. All right. Cool. So let's just run this, make sure I typed the code correctly. Yes, found the secret, got our zeros and found the secret. So now what's cool here in the new syntax, note that first of all, inside the switch statement, each case block now introduces its own scope for variables. I've got two variables I there, and they are two different variables for the first switch and for the second. Okay, so we have that particular feature where now each one of those blocks in the newer switch statement is its own scope. Even though we don't have braces, they're kind of implied. It's kind of cool. This also starts to show one of the interesting things that now happens with case and switch is that now order matters. You can see I'm now getting red squiggles here because it's telling me, you know what, you're never going to get to that code because every integer was found in the case above. So we now have unreachable code detected. Because case labels will be evaluated in the order that they appear in the switch statement, with one exception. I can write my default here. And of course, I still need a break. By convention, we'll probably write that particular case statement at the bottom, but the compiler plays a little bit of magic, and I can put it in whatever order I want it to be, and it will still get evaluated last. Okay? Don't do that, though. It's really ugly code. All right. So we've got that pattern set up so far. Awesome. All right, so now so far we've checked for integers. Okay? Well, we could do a case. Do our null case. And now suddenly we're going to pick up the nullable int that has no value, the string that has nothing in it, and then we're still not parsing our strings and our points yet. Okay, let's start looking at strings. So we'll start with just a case string s, and then we're going to write line that we found the string. Okay. Again, only a few things that can help us out. We've now found 3 different strings that are non-null. First one is the empty string. Second one is a bunch of white space. All right, well, let's add a string s when string that is null or empty. And you can see we found the empty string. We still have our white space string in there. Okay, well, that's easy enough to cope with. We'll add another one immediately following and say, instead of null or empty, let's just do null or white space, which I think is null or white space. And again, now we get to pull those in and we get things that have different statements in it. All right, so now we're finding whether or not we have an empty string. We're finding just blanks. We're doing those tests and we're putting that code together, and it's noticeably cleaner than it was before, both up here and down here. And then we can add our case for the points. And we'll find the origin. Okay, so we can do any kinds of tests on the object that we find. We can call any expression in there, test any value, test any properties, do whatever we want in a when clause. Okay? All good stuff. So effectively what we've done here, again, as we look at how this code looks, let's just evaluate a little bit about the structure of the code and the kinds of things that we're doing. We've taken this test to see if a value has something, extract information from it, and then do something with it. We've combined the first two. Test to see if a value has certain properties, extract it into a new value, and then do whatever we want with that particular value. Okay? We've expanded the case statement so that now case can work on any different kinds of variable, not simply numerics or the string. It can now work on any type. And in addition to just checking the type, we can check particular values of a type. I think I can also simplify this and just say there. Did it? Not in this build. Thought that was there. Okay. So we have a simpler syntax to do the test and to put our different work together. All right, so far so good. So now let's walk through in a larger project where we see some real life code as to what kind of ugliness happens in current, more imperative tests. And let's apply C# pattern matching to those. So I'm going to open up Node at Time. And I wish John were here in this talk. This would be fun. And to give a little bit of context to this particular code, what this method does, Node at Time is a big project. So this is why we don't use big projects for demos. I get to wait. Okay. What this particular method does is it's going to try to get a node of information for a particular culture to figure out what time zone you're in, what culture you're working with, and so on. And if we walk through it, we can see that it does is, okay, so if the provider that came in was null, well, we're going to use the current culture. Okay, so far so good. If the provider is not null, well, let's see if it is a culture info object. If so, I'm going to call get format info on a culture info object, get the right information for the culture that we're working in at this point in time, which is cached in Node at Time because you're probably using the same time zones for different tests. And then if it is not a current culture info or a culture info object, it's probably a date time format info, in which case we're going to create a Node at Time format info with the invariant culture, pass that back on, and that's what we use for our time info. And if none of those work, well, we want to throw a new argument exception because we really don't know what's going on, and you probably are using Node at Time wrong because it can't be John Skeet's bug. We know that. Okay, so let's change this to C#7. Well, I've got about 3 or 4 different tests here that I'm going to check for, so let's just do a switch. on provider. And the first one he has is that null. And if we get the case null, I'm just going to return get format info from cultureinfo.currentCulture. Okay, so I'm combining a little bit of stuff just to make this a bit cleaner, and that if you look what will happen in the original code down below, if provider is null, I'm going to assign it to current culture. Current culture is a culture info object, so the next test is going to succeed, and then I'm going to drop down into that return get current info. Okay, so when I first practice this, now I've got to read about 6 or 7 lines of code to make that conversion as to what actually happens in the case when you pass a null provider. It's nice clean code, but I still have to do a little bit of analysis to figure out exactly what's right. That new line I just wrote is really, really clear. You pass in null, you get the time info for the current culture. Groovy. Next one, let's now just say is culture info, and we'll assign it to the same variable name because that's a nice way to do it. And we're still going to return get format info, and now we're going to call that culture info.current, the variable that we just assigned. Hate to make a bug on stage because I want to submit this PR. And then the last one, I'm going to grab these 2 comments because I think that's probably important. And then we're going to have a date time format info. And here I'm going to grab that return statement. And I thought I grabbed the extra. No, yeah, I did grab the extra one there. There we go. I'm getting the red squigglies because I've left the code below that redeclares those same variables. And now I can delete this code. And if I didn't match any of the cases, then we're just going to throw that argument exception. So I've taken that 15, 20 lines of code that we had to snake through just a little bit and clean that up just a touch. Nice. Cool. So that's one real-world example of working with pattern matching to do a few different type tests and extract that information in a more clean fashion. So let's look at a second one. If anyone was in Damien and David's talk on Monday, they talked about building tag helpers. And they talked about building tag helpers. Yeah. Don't tell me you're going to fail on me on this one. All right, fine. I had this happen a few times because I've got a build that's slightly newer than they have. Okay, back over. Give me this. To switch to their branch. And let's close that and reopen it. And now we'll migrate that again. Yes. Cool. And as this loads, what happens with the tag helper is you get this tag, and the information that you need may be stored in a few different ways in a few different places inside the tag helper. And Damien talked about the particular code there. Starts right here at line 45, where we're going to look at this source, which is the particular attribute for the source. We're going to try to look at it as a string. If that's null, then we're going to walk through and look at this as an HTML string that may or may be, and if so, we're going to grab its value, and if that path is null, still, then we're going to do some other code. Yeah, this looks kind of ugly. And it's snaking through a few different cases there to unwind. If the path is null, we're going to start doing some stuff. We're going to try to see if it's an HTML context, if that HTML context or content has a value. If it isn't an HTML string and it's some different content, we're going to have to create a string writer and write the path into another variable, do some other bits, and then we're going to snake through and make this other source.value.toString, and then eventually we're going to use it down here. Ugh, this just feels buggy. All right, so let's work on this. All right, we're going to do some massive pair programming here because I'm probably going to need some help. Who's written tag helpers? Anybody? I'm on my own. Awesome. All right. So let's start and say, okay, so it looks like I actually want to switch not on path, but on source.value. All right, and if source.value is an HTML string, right, that's that first kind of test that's up there. So we're going to do a case HTML string, and let's give it a name. And it looks like we really care whether or not that value is null or not. So let's just be careful here, because there's this little bit here where I talked with Damien and David yesterday as I was working up this demo, where if you look very carefully, this is where I like pattern matching as a syntax. If you look carefully, path.source is HTML string, okay, and then I'm using the Elvis operator, so if it's null, this thing is going to return null. But there's another path where it is an HTML string and the value for it is null, which Damien said that's evil, it should never happen, but I don't like to introduce bugs. So let's just make sure that doesn't happen. So it could be possible. So I'm just going to say it's HTML string, and I'm going to say when HTML string dot value does not equal null. Because then I just feel a little bit better about this case. And if that happens, well, then I'm just going to say that path equals HTML string dot value, and that's good. That takes care of that part. Cool. Well, now otherwise it looks like what I need to check and see is if I have an HTML content, and it looks like that's path HTML content was the bit they used. And now I need to do this bit of code where I'm going to say, and it looks like I'm testing null there too, so let's actually, and I don't need to add that test, okay, because that source.value as HTML content, that will return null if it's not an HTML content, right? And we already saw that with a pattern match, it's not going to match if it's null. So I'm not going to get a null case in here. So, okay, I'm in good shape there. So now I can just copy this code because I don't really want to change it. And that now goes up under here. We've now set path. That's all good. Okay. What else could it be? So we've got an HTML string. We've got a path.html content. Well, looks like the other path that we might have is we're going to say source.value.toString. Okay. Sounds good. Well, I already kind of did that up there, unless it is a string. So if path is null, so if value is a string, looks like we had that up here before. So we should say case string s, and we're just going to say path equals s. And then we need our break. And now here we're just going to say this is default string, because now I feel a little bit better about the structure of that code. So it could be a string. It could be an HTML string. It could be an HTML content. It could be some other thing. So then let's go our default. And here I'm going to say path equals source.value $.toString. So it could still be null if, really truly evil things happen. And that's the case that kind of falls through here at the bottom. I'm going to add the $.dot just in case. Okay, so now I remove close to 20 lines of code there. And I've replaced it with, close to 20 lines of code. But it's so much cooler. Now, in seriousness, when I look at this code, once I get used to the fact that there's some new syntax here, I find that the structure of it is relatively easy and simple. Okay? And as I was walking through doing this demo, and this is, after practicing and analyzing the code and doing it and thinking about it, I feel in converting it, I had to understand exactly all the paths through those multiple if, else, what could be what value statements. Here there are 4 distinct cases, all of which are clear, all of which are easier to read. So that's one of the things that we want to do when we're adding new syntax into the C# language, is the developer that comes after this, or Damien when he reviews my pull request, should be able to look at and analyze this code and say, yeah, this looks pretty good. I think I like the way this is set up. I understand what it does. He may say nasty things, we'll see. But it looks noticeably cleaner. We have some really good stuff that comes into there. Okay, so do I make those pull requests? I'm actually not going to make them on stage, but I will do them later this afternoon. And the reason is I'm working on a build on this machine right now that has slightly newer stuff that kind of breaks the project system a little bit. So I can't build either one of these projects completely on this machine. And I'd like to actually build them and in the case of no time, run all the tests before I submit that PR. But it should be done later today. So 2 new bits of real-world examples of how, in both cases, what we think is, if I look at the change, no, I'm not going to look there. That's way too small. But if I look at the changes I made both here and in no time, we took code that required a fair amount of analysis and made it noticeably simpler. It's easier to analyze and understand. All right, so let's finish up with a few more ideas of where some things might go and some of the conclusions that we have. So what we really want to do here, what really is going on with pattern matching, and C#7 right now is taking a very tentative steps into this world. Pattern matching expressions enable a concise test and extract syntax. So in all cases, we're testing something and extracting information from it. And then we can, with confidence, we can work with that information knowing that things are set. And it's based on an object's shape. As you read some of the specs, one of the terms that you'll hear, C# has a normative type system. It's based on names. Typically, all of our classes have names, our structs have names, and for 2 objects to be the same type, they have to have the same class name or struct name. As we get into this idea of patterns and tuples and stuff, we're doing what's called structural typing. 2 objects have the same type if their shape is the same. And we'll define shape to say they have the same properties and same property types, same property names. Okay? So that's really what we're doing. We're moving a little bit more away from objects, a little bit. Could think it's dynamic, but it really isn't. It's all static typing. And then let's look back at this code just a bit and discuss a bit about some of the syntax rules. So I'm going to go back to the small demo. And some of the last rules that play into pattern matching syntax. Once again, C# trying to be a pit of success language. It's hard to write code that doesn't work. The scope of these variables, when you test and extract, should be the scope inside that block underneath it. The one exception to that is an if statement because of how a couple things work, which is that if I were to make this modification here, the scope of S right here is valid anywhere in this else clause. So that means it is in scope from here through here. Okay? Now, the scope of I is anywhere in the method. Okay? And that's kind of because to be an if statement, it has to be in the enclosing block. So for any pattern match variable, its scope is the block that's enclosing the is. However, we also have definite assignment rules. So if I try to use, let's say, this variable I, if I come down here and I try to do a right line of I, okay, it's in scope, but I will get a compiler error that says it's a use of an unassigned local variable. So it hasn't been assigned. The only time that I is assigned, it is definitely assigned underneath this if. So by combining this test and the extraction, one of the rules that is very important is you can't misuse those variables in a place where they didn't get assigned, when the test didn't actually pass. Okay? Other ones just for convenience, because it's just plain time, if you heard John on Wednesday, is the case blocks introduce new scopes in C#7 in terms of scoping variables. So you can squint kind of and see curly braces around those case blocks, so that is a distinct different I in those first two cases. Okay? So what's going to happen in the future with different pattern matching? Well, the best place to find out is if you go to your favorite searching engine, and if you search for Roslyn pattern matching and GitHub on any reasonable search engine, this page will be the first page you find. It's on the Roslyn repo, blob features patterns /doc /features /patterns, which is why I said search for GitHub Roslyn and patterns. We've talked about the is expression, talked about our type pattern, constant pattern we already know about, we're testing against the value. Some of these are the ones that aren't in the build right now. They're still being talked at and worked on. The var pattern more or less implicitly is there. Var will match anything. It returns the same type of what was there. So in my expressions here, if I were to do case var O, which I don't think, and then down here, O is an object. So you can see if I press the dot, it's kind of small. I get equals, get hash code, get type, and toString. So this particular case matches anything, the var pattern. It'll match whatever's on the right-hand side, and it will return the same thing, typed the same way. Wildcard and positional patterns are under discussion, under work. And then we will have the ability to override operator is also in here, where you will be able to define an operator is that can take an object and return a different type of object. So you can write your own patterns, if you will. The rest of these are pretty similar. And finally, we will have, I think Kathleen went through this somewhat, is destructuring assignment, which I think is more covered under tuples. But if you want to get involved in these discussions, you can participate here for any of the things that are still working. Finally, as we finish up and as I take questions, Effective C#, the third edition, is available now. Because it's available now, it covers C#6. I'm working on a second edition of more effective C#, which will cover the features in C#7. I'm going to close with a bit of work on what's going on in the .NET Foundation. where the managed language compilers are part of that foundation. There are a few bits of .NET that are now open source and public. I like the fact that it keeps taking me longer and longer to work on this particular slide as I walk through and watch what happens. More and more things are coming out. VS Test came out and was open sourced, I think yesterday was when that announcement was. So there are more different areas that are open sourced. So in general, what do we think about in terms of open source investments? If you look at the .NET framework, everything involving ASP.NET is. If you look at .NET Core, well, all of it. If you look at Xamarin, all of it. If you look at the infrastructure underneath each one of those, compilers, language, runtime components, .NET Standard, in many ways will be open sourced, fully supported cross-platform, Windows, Linux, OS X, Visual Studio support, and so on. These are out of date. I think we've had even more now, which is really awesome. And finally, a few links on areas that you can work through in terms of getting more information about .NET and so on. And take the survey, get swag, and finally, just how serious we are about open source. Even our swag repo is open source. If you have ideas, go ahead and submit a PR. So we have a bit of time left. I think the demos went just a little quicker than I was guessing. Are there questions on anything related to pattern matching in C#? Yeah.
You showed the example with the var in the case.
Mm-hmm.
How is this compiled? Because var disappears at compile time.
How is it compiled? How is the var case at compile time? Okay. Well, let's just put it right here. Okay. So, how is it compiled at compile time? What normally happens with var if I assign var to some object?
It's just replaced at compile time by the type.
By the type that's on the right-hand side of that assignment.
So it doesn't exist.
Right. So if I look at the right-hand side of this assignment, what that particular pattern is saying is, I want to take that object to test, and I want to assign it to a new variable obj. What is the type of object to test? The static type.
Object.
It's object. So what would be the type of obj?
Okay.
Object. Right? So the var pattern is in part there for syntactic niceness, and in part there because there are patterns where it is reasonably useful. If I want to do something in the default case, I can assign a variable and do some work with it. Okay? So var does return, the var pattern will return a new label to the same object. If it is a value type, it will return a new value type with the same value, right? But based on the static type of that object. Make sense? Okay. Should get rid of one more there. Other questions? Yes? I missed the last part of that.
If I use var pattern, and then I will use default.
And then if you use default.
Yeah.
I think you would get that. Let me just put that code back. Right, so I have var. If I remove all these, which is unreachable code, it looks like that works. I'm surprised that may be a bug. I may have to, I'm going to ask about that one, because that,
If you have null.
if it's null, yeah, it would pass, it would work with null. I'm going to ask Neil, because I'm not sure how the spec deals with that one. That is a really interesting case. It should do one of the two, you're right, but I think they'll have to ask. I saw another hand go up. That's a good one. Good question. Yes?
Will it work with patterns and generics as well? Can you do a generic case T where you pass the generic?
Okay. At the moment, I haven't gotten it working with tuples, and I don't know if that's just not in this build or not specified yet. Okay.
What about generics?
What about generics?
You do a case of T where
Let's think of what you mean here. So let me remove the var case up here. Okay, and let's say I were to write yeah. So we want a pattern of T, where we're going to take in a T thing, right? And now we want to switch on thing. Right. Mm-hmm. So you would want to do something like is, if, thing. Like that. I mean, that would always pass, right? Because it's generic. And if I did a case of T, if we did it with, so I'm going to switch on thing. And here, if I did a case T, okay, that would once again always pass. Right? Okay, let's just have some fun. Let's just make this crazy. Let's see if this will compile. Okay. Right? Why? Which derives from T. That could be, I'm not sure that that's correct either. Because not all T's are T derived. What's that? Yeah. Now, it's telling me that this case is handled by a previous case, which I don't think is correct. You guys are smart. This is good.
Is that an actual compile error, or is that just Visual Studio?
Oh, that's an actual compiler error. It's using the same analyzer. So yeah, if I compile this right now, I'm going to get, yeah. Switch case has already been handled by a previous case. So we can do things. Maybe. That's another good one. I'm going to have to ask about that one too. So we have two good ones to ask. The one there and the one about both the var case and the default case. Cool.
Follow-up on that. What happens if you change the argument type to be an object?
What happens if I change the argue? Oh. So if I were to change this to object. Ooh. I want to go back. I want to see what happens if we reverse them. Okay, that makes sense. Just adding that note so I remember that later. Awesome. Any other questions? Okay. We're getting close on time, and I will be happy to answer any questions up here toward the end. And again, I will post the slides and the demos sometime later today. Also make those 2 pull requests with the code we changed later today. And watch on the GitHub repo for comments and changes on any of the new pattern syntax that could be coming soon to a C# near you. Thank you very much.